ACCA, Developing Professional Accountants.
When we look at linear programming, the first thing we do is normally to identify an optimum solution. But that optimum solution is based on the original input data. One thing we can do is then consider the sensitivity of the optimum solution to a change in the input data. Now, at this level, the only element that we focus on are the input variables. In the example that we've been working on, that is the hours in departments A and B and C. What we want to know is how the optimum solution would change if, say, there were more or less hours in department A. To do this, we calculate something called a shadow price. The shadow price is simply the additional contribution that would be generated if we had one more unit, or in this case, an hour. Let's see how it's done. To understand how the shadow price works, we have to remember that both Department A and Department B were binding constraints. What I want to know is what would happen if I have one more hour in Department A. So all I've done is I've taken the original constraints that we had, but if you notice, I've added one additional hour to Department A. So what I'm going to do here is I'm going to calculate the optimum solution with that one additional hour, and I can compare and contrast that to the value that I presently have. So let's just solve these equations. Do you remember what we said before? We could say this was formula A and this was formula B. What we want to do is to eliminate one of them. So couldn't we say A minus B? 8x minus 4x is 4x. 10y minus 10y is 0. And 11,001 divided by 9,000 is 2,001. So if that's the case, x is going to equal 500.25. Now, it's quite important, this. When you look at linear programming, the assumption is that you can have part units. So you don't have to have whole units. So here, 500.25, I know it looks a bit foolish, but that is wholly acceptable. In fact, a fundamental assumption of linear programming. Now, if that's the case, then what we can do is to pump these values straight back in. 8x plus 10y equals 11,001. 8x is going to be what? 8 multiplied by 500.25 plus 10y equals 11,001. What do we get? We get 4,002. 4,002. Take that away and we end up with what? 6,999 equals 10y. So y equals 699.9. Now, I make no excuse for playing around with these numbers a bit. The reason why I've done that is I wanted you to be absolutely happy with where they come from, on the basis that you see that something quite sophisticated has happened as a result of adding 1 hour. What we're seeing is that before we had 500 units of x, and now we've got 500.25. Before we had 700 units of y, and now we've got 699.9. So, it's quite a complex idea, this. What's happened is that we've ended up with a little bit more of x, a little bit less of y. What we could do is this sort of thing. We could suggest this sort of thing. As A pushes out in that direction, what is effectively happening is that the optimum solution is going to slide down the Department B line. And that's really what we're seeing, because as we increase the amount of hours in Department A, we're getting more units of X, slightly, and less units of Y, and that's what we see on the graph here. So, the revised solution, we said, was what? It was x equals 500.25. y equals 699.9. The revised contribution is going to be 500.25 multiplied by 4 plus 699.9 multiplied by 8. And what I believe we get is £7,600.2. Well, okay, once we've got that, what are we able to say? Well, what we're able to say is that, well, with the additional hour, we got 7,600.2. Without the additional hour, we go back to the original solution of 7,600. Therefore, the shadow price is 20 pence. 20 pence per hour in Department A. Now, that's the basics of the shadow price. And remember, what that is the additional contribution generated by having one extra hour, or, if you wish, it's the additional amount we are willing to pay for one extra hour. Two sides of the same coin. Additional contribution or additional amount we're willing to pay. Right. So, what are we saying? As A increases by 1, X increases by 0.25 units. Y decreases by 0.1 units. Contribution increases by 20 pence. And what happens to Department C? Well, this is an interesting one. What we have to do is this. We've got to take those two changes and pump those into the Department C constraint. So that's going to be a bit odd. Okay. So let's go back and look at the Department C constraint. If we look at the Department C constraint, each unit of X requires 12 hours and each unit of Y requires 6 hours. So hold on a moment. Couldn't we do something like this? Couldn't we do something like this? In Department C, each unit requires 12 hours of X. And we've said that we're going to have 0.25 more of X if we introduce one more hour in Department A. In Department C, each unit requires 6 hours of Y. And we're going to produce, what was it, 0.1 less of Y. So what's going to happen in terms of Department C hours used? We're going to have 3 additional hours because of X, 0.6 less hours because of Y. We're going to say 2.4 hours additionally are used in Department C. So quite a complex little situation here. A lot of things changing. Now, I will say that I've looked at the effects here because sometimes the examiner will have a slightly more open-ended question at the end that's in relation to the impact of the shadow price. But my view is this. From the perspective of scoring marks, you've got to make sure you just nail the shadow price first of all, and everything else is a bonus. So we've looked at a situation where you have 1 additional hour in Department A. Of course, we could do exactly the same thing in Department B. Note, all I've done is said where before we had 9,000 hours, now we have 9,001. And again, you can solve simultaneously to establish the revised solution for Department B. And once you've got that, you've got exactly the same sort of analysis that we talked about before. Now, there are always good marks in this particular area, so be able to calculate the shadow price. I think if you practice these both yourself again, it will make a lot more sense than just watching me do it. One more thing before we wrap up in this particular area. One more area before we wrap up. Let's look at Department C and its shadow price. Now, we have to remember that Department C is not a binding constraint. That means that Department C does not determine the current optimum solution. In fact, when we previously did the analysis, we identified that Department C had unused hours. So, if we have one additional hour in Department C, will it increase the contribution? Well, the answer is no. As such, what we have to remember is Department C has no shadow price because they are a slack variable. A slack variable, or if you wish the other term, a non-binding constraint. When we look at this particular topic area, there tend to be premium marks for anything to do with shadow prices. I would strongly advise that you play around with this example before you even contemplate going on to any other example.